Hello, all. Good morning, good afternoon, good evening, depending on where you're coming from the world, all over the world. We have so many attendees coming from everywhere. I'm excited about this. My name is Bryce Heventhal, and welcome to AI in Manufacturing, an Autodesk discussion on the future of the industry. I am from the design and manufacturing marketing team at Autodesk. I'm an engineer by trade, by heart, and I'll probably be an engineer till the day I die. And I'm an AI enthusiast. It's my pleasure to host this LinkedIn Live today with our fascinating guests who, along with Autodesk, are bringing the future forward in our industry. Please feel free to leave comments and questions for myself or the other panelists in the chat. We will be answering them throughout the conversation, and at the end, we will have a Q&A. And now I would like to introduce our guests. You, Scott.
Hi, I'm Scott Sawyer, co-founder and chief scientist at Paperless Parts. Paperless Parts is quoting and estimating software for custom part manufacturers. We help with workflow management, costing automation, providing a good customer experience to your customers, and we have APIs to connect in with the rest of the ecosystem. A bit about myself. Prior to Paperless Parts, came up through the defense industry, and I've always been involved with software that interacts with the physical world. Fun fact, took a grad class about artificial neural networks about 15 years ago on a whim, and it turns out that's pretty much all we talk about anymore. So for the last 2 years, I've been focused on bringing AI into the Paperless Parts application.
That class really paid off. Let's go to you, Justin Gray.
Hey, I'm Justin Gray. I'm the CTO at Toolpath Labs. We're an AI CAM automation company. We focus on coding and estimating as well, but also CAM automation. We also recently acquired Chatter to integrate machine monitoring and close the loop there. A little bit about me. I worked at NASA for 18 years, designing advanced optimization software. And I decided to leave there and come over here to take those skills in an adjacent field and bring them over to AI in manufacturing. It's been a really fun ride.
We need more astronauts in engineering, so that's great to hear. And let's go to Omar.
Hi, I'm Omar Fergani. I'm the co-founder and CEO of 1000 Kelvin. At 1000 Kelvin, we develop Amaze. It's the first copilot, AI copilot that is driving the end-to-end workflow for additive manufacturing, from quotation to build preparation to recipe generation. A little bit about myself. I call myself a manufacturing enthusiast. After my grad school at Georgia Tech, where I did manufacturing, went down in Houston, worked in manufacturing, and then moved to the software part of manufacturing at Siemens for a few years. So I've been a little bit like Scott at the intersection of the digital and then the manufacturing world. And I'm really happy to be here.
Yeah, I'm excited for this conversation. I'm really excited for all three of you to be here. So let's kick it off. AI is a big buzzword in the industry, I think on every industry, but what does AI mean for you in manufacturing? And that's what I want to start with, just to get your answers. And let's start with you, Justin.
Sure. I mean, like there's the mathematical definition of AI or machine learning, right? I don't think that's super relevant. For me, AI is really about improving the efficiency of people in the shop. I know Al, CEO of our company, Al Watmo, likes to say that we need to find a way to make 10 times as many parts with twice as many people. I think he might be a little optimistic. We might need to make 10 times as many parts with half as many people. We'll see. It depends if we can get enough people to come into the industry or not. But in order to kind of find those increases in productivity, it doesn't mean work harder, grind harder. It means being more efficient. It means finding ways to have people run more machines. And it means taking some of the simpler tasks that are repetitive off your hands, making quoting easier, making programming easier, letting you focus on the more complex parts where your skills are really needed. I think sometimes people can get worried or lost in the idea that AI is going to replace their job. I've never actually seen a lot of automation replace high-skilled labor, and manufacturing tends to be high skill, at least for the hard parts that bring the money. I think what ends up happening is it's an arms race. So the more high technology you have helping you go faster, the harder the parts your customers will send you, and they'll expect them to come in the same amount of time as the easier parts did later. So for me, AI is really about helping people move up the acceleration curve and find ways to make more parts more efficiently.
Amazing. And I know paperless parts, you probably have a big opinion on this as well. Scott, what do you think about AI in manufacturing?
Justin, I think you put it really, really well. It's all about addressing this huge labor shortage we face in the industry, and bringing whatever tools we have to bear on that problem. So, you can nitpick about the technical definition of what's AI and what is not AI. People using it don't really care how it works and what's powering it. So, I think it's a lot of people, their minds immediately go to things like robotics, CAD and CAM. Those are kind of like real front and center use cases for AI. Where we found a huge opportunity is interpreting technical part data. We work with custom part manufacturers. And a system like Toolpath, right? If you give it model-based definitions or Step 242, that's such a leg up. What our customers tend to be dealing with is really hard to work with technical data, right? So old drawings, maybe they're scanned from decades ago, and maybe the 3D model is only a small part of the story. And where we've been focused is using AI and all sorts of technical tools to help kind of reconstruct that digital thread that seems to get broken in the manufacturing supply chain.
I can't agree more. I love to hear that, especially like that. It really depends on the application. And Omar, what do you think is going on, especially with your 3D printing? Where do you see AI in manufacturing?
Well, I think it's very hard to add more than Justin and Scott, but I have to agree with what they say. But if we take a step back and we think about AI in manufacturing, well, first, two things come to my mind. Number one is the fear, and I will explain that. And the second one is the growth opportunity. Beyond the efficiency and being faster, what is the growth opportunity? When I look at all what's happening around AI, the first thing that I see is actually AI is not a disruptive technology. The supply chains and the physical world is still the same. Maybe AI actually is creating higher demand for energy and more manufacturing. But what is very important to know about AI is very transformational, maybe the most transformational technology that we would have ever seen. And that's why in the top of the agenda of all the CEOs, because obviously they see the business opportunity, the growth opportunity. And how can we bring this message to our customers? Well, I think as Scott was mentioning, I think this is a great opportunity not only to make your things more efficient, but really to address the growing demand. I mean, we see a lot of optimism in the West about bringing manufacturing back. I think a lot of people think about the fear. I think about look at the massive opportunity, the high demand, the investment. How are we going to face all that with all the knowledge that is missing? Now, when it comes to additive, I would say get a little bit into the technicalities of things without being technical. I think, when we talk about expertise in manufacturing, translate immediately to me to a word that is very important for us, which is trial and error. Manufacturing is all about, the expert. Who is the expert? Didn't have a PhD in a machining process, but someone who have done it for hours and days and years and figured out what works and what doesn't work. And I think that's the biggest opportunity here. Manufacturing processes are very complex, very sophisticated, have physics, complexity, multiple parameters, multiple materials. And those experts, as Justin was saying, we have a shortage, is very clear. And I think compute is the solution. And that's really our biggest bet at 1000 Kelvin.
It's amazing to hear. I think that one of the things that my next question for all three of you is AI. I think we see that as a vision, especially manufacturing. We're still in the early days. How do you see these trends manifesting today? And where do you think it impacts bottom line for companies, business leaders, organizations, even all the way up to the big names of the industry? Let's start with you, Scott.
Sure. Well, so we work on the estimating side of things, and that has a huge impact on bottom line. So if you're able to pick the right jobs, right? Pick the work and win the work that's actually going to be high margin for your company, that's how you win. And then over time, as you make a part over and over again, sure, you're going to reduce your cost on it and have a learning curve. But the quote is really what establishes the starting point that you're going to improve from. So it's hugely important to bring as many tools as you can into that phase of the process.
Amazing. Yeah, and let's go to you, Omar. How do you think that the trends are manifesting today, and where do you think it's impacting that bottom line for businesses?
Well, I think that this is the million-dollar question. Everyone is trying to see where is this going to translate to dollars and growth and opportunities. And I think it's a question of time, obviously. And we are very lucky. We are in the slowest industry in the world, manufacturing, which is a great thing, actually. So I think we have to be patient. And I think it will really translate definitely to a growth opportunity that will translate to more efficient processes and therefore higher profitability. But if I have to think about it from a pure manufacturing viewpoint, I think the biggest opportunity I see is a new excitement around continuous improvement. AI coming as a tool now will open the discussion again about how can we make things better in every single step. And I was in a factory recently and people are telling me, well, we have this quotation department. There are 6 people, probably they're going to disappear. I'm like, why do you think about it like the Japanese? They have done continuous improvement for many years. They never fire anyone. They just they put it as a culture. And that's what I want us to all communicate to people today, that AI is the opportunity for all of us to come back, look for that efficiency and move the teams, get the excitement back. And this is the message all of us we share here. And I think that's what we should hammer to people. So for me, it's number one, it will take a little bit of time. We need to work and collaborate with the machinists, with the manufacturing folks. And I think from a translation to growth, I think I have no doubt about it. This is just a question of time.
Last but not least, Justin, what do you think?
I'm going to turn it around a little bit. I think Scott had a really important point about helping companies make their quotes really accurate and get them right. It's not usually the quotes you get right that hurt you. It's the ones you get wrong. Those are the ones that you really remember. They cause you the most pain. But if we extend that a little bit further, why did you get that quote wrong? Did you miss a key side hole? Was it, a feature like 100 thou deeper than your longest tool and you just didn't realize it? Was there just more machining time in it than you thought, or less, or stock cost? And extending that just a little bit further, if you're the one submitting the part for a quote, why did you get no quoted? Why does this $5 part come back as a $15,000 quote? And I think, at Toolpath, originally we used to joke and say that we were trying to make peace between the machinist and the part designers, one part at a time. There's this real broken communication system where you just kind of toss RFQs over the wall and then hope you get something back. A lot of shops talk about how the quicker they can quote, the more likely they are to win the job. And there's certainly some truth to that, but the person submitting the part doesn't really get a ton of feedback as to whether they submitted an easy to machine part. And I've seen, working on the other side of the fence, I've been on the side of folks that were requesting parts. I've seen people who requested a part and they got back a ridiculous quote because they put some feature in there that they didn't realize was expensive and it wasn't critical at all. They didn't care. So I think the most exciting trend for me about AI is to actually grease the wheels of that communication process. If we can have AI be like a junior manufacturing engineer giving feedback to people who are submitting quotes or RFQs rather, so that first round of manufacturing iteration can be done much quicker, then that's what starts to give people the real power. I can't remember who said it, but somebody said that the real power in AI isn't going to be from helping people make parts that were already designed faster. It's going to be in teaching people who are designing parts how to make them more manufacturable. And I thought that there was a real synergy there. I think both are true, but I think the trend is going to be for AI to facilitate that conversation more, to give people designing parts the ability to design more manufacturable parts, and the people who are making parts to make more of them faster, turn quotes around quicker, get parts on the machine faster, more spindle uptime, things like that.
As an old engineer, you speak my language. I pissed off many manufacturers, basically exactly what you just said. That makes total sense to me.
Can we riff on that a little bit?
Yeah, of course, Scott. Take it away.
It's a really great point. And, I think some of the first places we've seen the AI is in like the CAD world, where people are now designing just increasingly difficult to manufacture parts, right? Because maybe they're trying to take weight out or do these kind of generative forms, and it's moving in the wrong direction. And then, as we get into real systems that give you real DFM feedback, right? And there's been, toolboxes and CAD systems that'll give you DFM feedback for a long time. But if it's not tied to an actual manufacturer, right, it's way less actionable. It's one thing to say that's a deep hole, but a deep hole to one shop is completely different than the definition for another one. So what you need is actionable real DFM feedback that impacts your ability to procure that part. Not just
Yeah,
hypothetically bad, DFM warnings.
right.
But
Just showing somebody, hey, here's a sharp corner is not good enough anymore. Yeah, I think that's really critical. That's another important trend that I think AI will have to see. I'll have to rise to the occasion for. But good AI has to give a different answer for the same part at two different shops, or even two different machinists. Like you said, what's a challenging feature for one is not for the other, and it needs to reflect that, right? And that gets to saying yes to the right parts and no to the wrong parts. But a yes for me might be a no for you, and vice versa.
but that poses the question ultimately of the universality of these tools if you have to train models specific to every company. So I think that this is the discussion that I guess our teams are dealing with, the edge of the frontier. At least from additive manufacturing perspective, the laws of physics are ruling. You're in a dark room, it's a laser, it's thermal. There is no need to make it specific. And that's maybe why we are physics focused as a company. But I do see that challenge definitely.
And I can't agree with you more. As an engineer, it's sometimes just hard to know what tools are in the shop that we can use this sort of radius. And I think that's where AI can actually help us, especially I don't know which printer we have in the shop. Like there's so many aspects to manufacturing that as an engineer, you kind of need a little bit more information that I think AI can help.
Yeah.
As many people, I think this is in manufacturing, we're a little slow to all changes. I guess my question for you guys, how do customers get started with AI in automation? Like, where do you think the first steps are if I was a small shop all the way up to a big organization? Like, what are the first steps to getting into it and making sure that we're successful using AI and automation? And I'm going to start with you, Omar. This one.
Ooh, this is a hard one. Uh, okay, so I have to be based here on few experiences that we had. I think we released our first models in 2020. There was no ChatGPT, so people would ask me, "What's this approach?" And I would say, "Well, it's a CNN," and then they don't understand it. They think I'm a crazy guy, and you have to call it a data-driven approach. But anyway, we see two trends, and I'm not sure which one is going to work. The first one is really the CEO-driven approach, where he understands that this is a transformational technology. He sees bottlenecks in his quotation, in his CAM preparation or build preparation. He sees that he has a low yield, and he definitely want to have an answer to that. And all of them are well informed and technical. So then they go and scout and find companies by problem specific. I think this is the most successful in our view, because then there is a management backup. They take a little bit of time. They give a little bit of bandwidth to the collaboration, because obviously, as you could imagine, there is always friction. When you bring a new company, the engineers are always pushing back. I have some anecdotes about that, but maybe for later. The second one is really the nerd, the engineer who is excited. He tested it. It makes his life 10 times, his work 10 times faster. It reduces those friction steps that he has to do. I give you an example. Build preparation, for those who are not familiar, is you have the part, 20 parts per day, and you need to figure out which orientation, where to put the support. This is a nightmare. Think about it as a mechanical engineer, because you're trying to solve a problem. I need to suck heat from here. I need to anchor it here. And this is not fun, to be honest. Think about it. I wouldn't want to do this the whole day. So if you have a tool that's going to automate this for them, they definitely go and do it because they see the benefit. So I see these two trends. Both of them are positive. But from an ROI perspective, we're entrepreneurs at the end of the day. We want to have the impact. I think the CEO-driven approach is generally the most successful I see at this point.
I agree with that too. Leadership, strong leadership always makes bigger changes quicker. Justin, let's go with you.
I think if I rewound the clock 5 years ago to 5 years and we were having this conversation, you would have said, if I'm a small shop, how do I get started with automation instead of AI? And I don't think my answer then would be that different than my answer now. Standardization, processes, tool libraries. I think, most people nowadays, when they buy a machine, are at least thinking about pallet pools and robots, right? How do they get more efficiency out of that? Well, if you're going to do those kinds of things, if you really want lights out, you have to have standardized tool libraries or even just tool libraries. If you're not ready to sit down and invest in standardized processes and tool libraries, if you're not ready to describe your shop to an AI in that way, then I would say that you're not ready for automation. So, or AI. So the steps, I think the first steps are the same. Build a standard tool library, figure out how you want to keep stock in stock, what size stocks you want to work with, what materials are you comfortable working with. You have to be able to tell the AI those things so that it can represent your shop properly. Getting back to my shop should get a different answer than Scott's shop or Omar's shop. I don't know if the same is true for additive manufacturing. The process is a little bit more general, but even there, I would say, like, what materials do you like to print with? Are you doing metal manufacturing or plastics? If you can't describe that in a very standardized way, then you're going to struggle to adopt AI because it's expecting those kind of inputs and it's expecting them to be consistent and accurate, right?
I'm gonna actually quote. Yeah, I'm gonna take stock of your stock. I mean, I love that quote there. Scott, let's go to you.
Yeah, I mean, I agree with all that. Also, let me try to offer just a different perspective. Certainly agree with everything that you both said. But I think of AI and your ability to adopt it. There's kind of a spectrum of tools and platforms out there ranging from like really general purpose to industry specific to like fully custom solutions, right? So, anybody who works on a computer and deals with text, images, videos can use these general purpose tools like OpenAI, ChatGPT, Google Gemini, and there's other ones now. And you could do that today. You could literally go sign up for those tools today and probably find a way to speed up something you do, right, by using these tools. But they're really general purpose. They're really subjective. Like you would not, for example, upload a 3D model to one of these tools and expect it to tell you accurately how to manufacture it. But will it help you write an email faster? Will it help you read stuff faster? Sure. Then there's industry specific stuff, which maybe you can't start using today, but you can start using pretty quickly because you're looking at 3 companies right now that have integrated AI into industry specific tools. So we're kind of doing that work for you. That's a great way to get into it at a deeper level, right? And then if you're a business that has a really specific problem to your business, you can dive into these platforms and develop or work with somebody to develop fully customized tools. And that's where the platforms like Azure and AWS are going to come in and give you something to build on.
Can't agree with you more. And as some of the like biggest AI companies that I see in manufacturing, you three all have different parts of the business like pushing the limits of AI in manufacturing. What do you see as our role as like technology companies and our partnership with you all with Autodesk? What do you think our role is stewarding our customers through these trends? It's not an easy problem because we have to all migrate these legacy customers all the way over to the people who are trying to push the limits together. Where do you think that role sits with us? And I'll start with you on this one, Scott. Let's go in reverse.
APIs.
Oh my God. My answer.
Yeah. No, I think that's the big thing is the industry is still really moving to the cloud. That is certainly not a completed transition yet. And some stuff may stay on-prem for a really long time for some really interesting and good reasons. But as we do move to the cloud, we have to make sure that we kind of force software vendors to truly embrace the cloud principles, right? And have open APIs that anyone can work against. You can't just take an on-prem offering and I'm looking at you guys certainly know this, right? You can't just take an on-prem offering and host it somewhere else and call it cloud. That's only half the battle, or probably less than that.
I
Definitely.
can't agree with you more. Omar, I'm going to go to you because I saw you jump out of your seat when he said APIs.
Because to the point Scott made, there are a few things that are happening. Yeah, there are definitely the problems are so specific and so sophisticated. I like it, Justin, how he was describing the tools and the edge. I mean, you have to be really focused to build an AI capable of doing super duper good machining things. You cannot do everything. And same with Scott, he was describing his workflow. But when we go to our customers, job shop, contract manufacturing, they need all these tools. And none of us could claim that we're going to be like the all solution for this. So I think the APIs is a super important topic for the future of entrepreneurship in manufacturing, as well as the satisfaction of our customers. So I did definitely double down on that. And I think this discussion today is very important from that perspective. And the second point, I think we need to also a little bit reverse the narrative of some of the incumbents that have told people that's all in one platform, buy from me everything, I have everything for you. And this is really what I love about Autodesk, because we're a partner, we're already integrated, so this collaboration also in going to the market, talking to the customer is also important. So both aspects.
Yeah, I can't say it enough. APIs at Autodesk is so important for us because it makes it extensible for partnerships like you guys all to make like your application, whether that's super niche sometimes, but it is very powerful for that persona that they're going after, all the way up to like the mass market. Let's go with you to Justin.
I like the API's answer. We've certainly been asked to make an API for Toolpath a few times. It's on our roadmap, but I'm going to go a different direction. I think that's a pretty insightful answer, but I also think at least Toolpath's role, I'll speak for Toolpath, but more generally, I think this is a valid statement. Our role is actually to turn AI in manufacturing into something that our customers can have a conversation with. Fun fact, the first research on AI actually predates the first research on machining, NC machining, not machining itself, but numerically controlled machining. I think by a year, it's like 1946 and 1947 for neural networks versus numerical control. So AI has been around for a long time. I took classes on it back in 2010, I think, 2012. But the world changed a little bit when these LLMs, these large language models came out and people could interact with it and say, oh, no, that wasn't right. Rewrite it in a more happy tone. If I translate that to machining and milling, I don't want to use that tool because it's broken, switch to this tool right now, or that created a lot of chatter. We need to develop a language for manufacturing that can be consumed by an AI. It's a little technical, but ultimately AIs, they just take sort of rows of numbers, right? And so when you input something into a large language model like ChatGPT, it's converting your text into a big giant array of numbers. AI for manufacturing is no different. We have to figure out how to represent your part as a bunch of numbers, your tools as a bunch of numbers. But we need to do it in a way that's very relatable. And it's really critical because that's what enables somebody to specify their intent and get what they want out of the AI. I think if the AI becomes really prescriptive, then it won't be adopted. If it's saying you need to make your part this way, then people won't use it. They need to be able to say, I want to make my part this way, and have the AI help them get there. So we need to make sure we keep that in mind, that the users are in charge. The AI needs to listen to them, for lack of a better word. It needs to ingest their intent. And it's really challenging to develop sort of vocabulary and inputs and UIs that let them do that. Sometimes it is just text. Sometimes it's pictures. How do I machine this part? Sometimes it's, color coding and things like that. But yeah, and it can be like really simple stuff. Like, you mentioned, Scott, how like the drawing is kind of the king in manufacturing, and sometimes the part is just the model is just a small part of it. I can't tell you how many parts I've gotten with a 1/4-20 hole where the diameter of the hole modeled in the part wasn't anything related to anything 1/4-20, right? And so to express the intent of like, I don't care what the cylindrical surface in this model is. The GD&T says it's 1/4-20, make it 1/4-20. We need an AI that can consume that type of stuff. I think for 3D printing, you need to be able to say like, please put the support here. Or this section needs to be really stable and not have a lot of residual stress. Those are the kind of intents that people can specify so that they can then trust that the AI will respect it. So I think that's our job, is to figure out that language and let people specify their intent. and have that conversation with the AI so that they're in control, because otherwise it won't work.
But
I-
Justin, just to react on that, don't you think that image recognition already is able to read drawings today and see where the tolerance need to be, and from that derive where the support needs to be? I think where I agree with you 100% is we need to go back to an ultimate language that defines all this. And from my perspective, honestly, it's an intersection of math and physics. I would tend to say more physics because at the end, your geometry is a geometry, can be described mathematically. The tools are also tools. The physics of material is known, the stiffness. So I do understand where you're heading. It's definitely a language that is more sophisticated so that the AI becomes more a true co-pilot. I just think that we are close to that than what most of
I
people
think
think.
the puzzle pieces are there. I think Scott could comment on this, but there are some junior engineers out there who make some pretty wild drawings that maybe have some conflicting GD&T on them. But I can also speak, for my part as a machinist, there are some times where I have to make changes to a part that aren't on the drawing, either because I know that's what my customer wants, or maybe you gave me a square corner, but it's a stainless part and all I can get is a round corner end mill. There's a lot of hidden information in manufacturing that's been developed of like, well, I know what my customer wants. I know how they want me to make this part. I know what the drawing says, but actually, we do it this way and everybody's fine. I've even heard stories where like critical parts for aerospace industry, like, somebody discovers 20 years down the line that there was an incorrect thing in the drawing and they want to file an ECR for it. And the company's like, we're not admitting that we've been making this part not to spec for the last
So let's
20
build an
years.
AI that detects all these mistakes in the drawing. I think
Yeah,
it's
but
more
I mean, so
critical
that
now.
right, so that goes back to the earlier point of better DFM and closing that loop.
Yeah.
Yeah, I think the puzzle pieces are there. Image recognition is there, LLMs are there, but if we don't put it together in a thoughtful way and create the right vocabulary, then people won't be able to use it. And capturing that hidden information and giving a place for it to come into the AI, like, oh, that's supposed to be, the drawing says both, that pin and this hole are both, half an inch plus or minus 5 thou, but I know these are supposed to be a slip fit. So really I need to use the top of one tolerance and the bottom of the other. I understand that intent. I need to be able to communicate that to the AI or it won't be able to make that part. And it doesn't exist on the drawing right now, right? So
Totally. And we run into that. So I've looked at a lot of, real industrial prints, and the variation is wild, completely wild. And they're actually, yes, there's a lot of image recognition, computer vision stuff out there. But if you're trying to get too close to 100% detection of every call out, everything you might do on a print, right? And then try to link it back to a 3D model to figure out that that thread actually belongs to this model, hole, this cylinder. It's not a solved problem completely. There's definitely assistance you can provide, but it's still really tricky. So, we've certainly been working a lot in that area, but there's more to do. And, you got me thinking, Justin. I wanted to go back to, you made this, what was the really great point you made? Can you remind me? You probably don't know what I'm talking about.
the one I just made right now.
No. When you were talking first before Omar.
I don't know what I said. I said
Okay.
About specifying input languages and
Yes.
there
Thank
you
you.
go.
The another thing, what we've seen, manufacturers, typically not early adopters of new technology, they do not want a black box where you're just getting an answer from some system, right? They need to understand where it's coming from, and get more context to really be able to trust it. So I think it's our job to develop user experiences that really deeply integrate the AI, right? And actually give someone something to interact with, beyond just a black box. One of the things we like to say here, AI makes suggestions, but humans make the decisions. That's what we really need in the manufacturing industry.
That's really a great point, Scott. And I think the challenge for us is always also not to push it too low until the value is not delivered anymore. So this is really a great question. The human and machine interface when it comes to these technologies, where do you bring the full control to the human? Where do you do automation? So we see this a lot. And to your point, these companies, most of them have quality system, qualification process. They need to explain how they did things. So this is one of the topic we see also in aviation industry is like, okay, well, I'm going to use this technology. I see the benefit. Now I have to explain everything to the FAA. And I'm like, well, I don't know maybe how to explain everything about all the physics behind. So it's really exciting, challenging, and it's going to slow the adoption. You're absolutely right.
And we call that AI that shows its homework. Um,
Explainability. Yeah. No, that's a good point.
The really classic example for us is, we'll look at a part and say that we need, we are going to use a 1/4 inch end mill for this part. And the user will come back and say like, I'd really run my 1/2 inch or my 3/8 on that. I don't know why I need a 1/4. And it turns out there's some, fillet in the geometry that requires the 1/4 inch end mill. And if the AI can't explain that this corner, this fillet is why we're using that end mill, then they don't trust the results.
Yeah.
I can't agree with you more. I think that especially us engineers, we think we're the smartest in the room. So I think we think we're smarter sometimes, but we need that explanation that like why the tool is using this specific rule or this specific path to do that type of manufacturing. So AI has come a lot, very far in many different facets with manufacturing. Where do you see it going next? How do you see these trends evolving? That's what I would love to see. What's the next big hurdle? And let's start with you, Justin, on this one.
I think our hurdle is really in that AI showing its homework. I think building trust in the output is the adoption hurdle. There's not many people out there when they trust the output and when it's working faster for them, they aren't going to love it, right? When you switch to your new favorite tool, you're scared, right? Your tool vendor, whatever, your new rougher, you're scared the first time, you're a little less scared the second time. By the 5th time you're running parts on it, you don't even think about it anymore. So we have to help people along that adoption curve by showing our homework, by making sure that they can interrogate it, and by giving them opportunities to try it in a trustworthy way. That's actually why we start with quoting and estimating, because if we can't estimate and quote your part, if we can't help you get that part ready for RFQ, then why would you trust us to automate the programming of it? And so, we want you to trust us in estimating and quoting, and then hopefully we'll earn that trust for programming.
Love it. And then you'll become an advocate for essentially after you actually trust the software. Omar, let's go to you.
Yeah, I mean, Justin got me into this topic specifically, and it's really a big one because obviously engineers are still the decision makers when it comes to processes, and you bring a totally different way of working where they lose a little bit of control, and therefore many topics come to responsibility, liability, explainability. I think we all as a community would love to hear your opinion separately, guys, how you deal with that. So I think we need to collaborate also on these topics. So this is from an AI and manufacturing perspective. I see it as an issue. The second is, I think, more of a macro issue. I think that there is always a tendency to adopt more efficient technology when there is an increase in demand and optimism. So I do see I do see a little bit the economics there playing an important role for us to accelerate the adoption. At the end of the day, AI in medical is going really fast. In other applications, in manufacturing, is always a bit slow, and we wanted to see it a bit faster. I assume we agree on that. So I think if there are some opportunities to grow the businesses and to get people to invest more in this technology and take risk, I think the investment side is going to be a risk here also for us to continue innovating at the end of the day and building these models.
Love to hear that. And Scott.
Yeah, we've outside of manufacturing, you say AI and it's really become synonymous with LLMs. And those things have been trained on huge amounts of text, image, and videos, but all very kind of general purpose stuff, open source or kind of similar to that. And Omar, you talk about physics, like that's like we're dealing with real world constraints, right? It's manufacturing. You're not just spewing out new text or images, right? And having that be super valuable. Sure, there's applications for LLM for folks who I mean, for anyone who works on a computer, really, it can help you manage RFQs and maybe help your sales process and help with communication, maybe even explainability, some of that stuff. But at the end of the day, we're here in a world with really kind of unique and distinct data that isn't available to these foundation models when they got trained. And what we're seeing now, I think, is companies like us, we're building our own AI models based on these more industry-specific data sets. And the reason we have to do that is, it drives much more accuracy, right? So it's much more objective results coming out of these AI models. It's going to be more cost effective in the long run because you don't necessarily need a massive model to solve the problem at hand. So it'll be cheaper too in the long run.
I just
Yeah,
want to
I
add
can't.
one point on that, Scott. You made me think of this. I used to work in a software company, and when we sell the software, no one is asking us why I need to see the physical outcome of your software. And we are in such a crazy category where actually I'm selling a software, but I'm being judged on the outcome in the physical world, which is a totally new, crazy thing also from that perspective. So, yeah, your point is really interesting.
I want to follow up on that too. You raised the point about, giant amounts of data these LLMs are trained on. I call them hoovers, right? Like they're trained on the entire internet. It's pretty wild. We get asked a lot, does Toolpath use my data to train its model? And I think that's important for us, at least for Toolpath, but as an industry to recognize that we are not going to have the same opportunity to collect like infinite data and compute these kind of like mega models. And so the models need to be not just specific to an industry, but sometimes specific to a customer. So we actually put quite a lot of thought into building AIs that you can customize with your constraints, but don't require your data to behave the way you want them to. And so just being upfront and honest with customers about what's happening with their data is a question we get all the time. Are you using my data to train? Where does my data live? How long do you keep it? And I think having a clear answer to that is good, but being ready to say we don't use your data to train is also pretty important.
I can't agree with you more. We get that question asked constantly, especially all types of customers, whether they're every industry, the size. We get that question asked many, many times of like, how are you training your data model? It's going to be something in the industry that we're all going to have to solve together, which gets me to one of my last questions. I would love for each of you to describe the partnership you have with Autodesk and like what you why you've chosen Autodesk and Fusion as your partner of choice to make your application better. Because we see you guys just extending the capabilities for our customers to be able to do more, faster, quicker. And let's start with you, Justin.
Yeah, sure. Linking with Fusion was such an easy choice for us. First of all, to be frank, you have the best APIs out there in the CAM world. And to produce CAM automation, it's really important to us that we're building toolpaths that a user can customize. So we need to push that down into Fusion, not just as a static toolpath that can't be changed, but as a native toolpath. And so having access to those APIs is critical. Also, we felt that the user base of Fusion was really the most open-minded out there. They tend to be the most quick to adopt new technologies. And so we felt it was a good fit. Also, I think Fusion has best-in-class automation support already for CAM automation, templating and configurations and things like that, that really make it a good fit for extending more automation. You already have a customer base out there of people that are building those kinds of processes in their CAM system and want more. And so that's why Fusion was an easy choice for us.
Yeah, that's great to hear. Let's go to you, Omar.
Yeah, just to repeat what Justin said, I think first of all, the customer base is amazing. Early adopters, a lot of innovators, a lot of people who are willing to test and get new technologies on hand. So for us, that was absolutely no-brainer. The second is the no barrier. I mean, the API integration took us literally a few days, which is unbelievable. I was at first scared that it would take us like a month of project and discussion. It was like super easy. So from that perspective, also we learned a lot. And third is I would say also because I go a lot, I'm outbound. So I think that the ecosystem of Autodesk when it comes to innovation, to people, to event, to good discussion, to visibility, to a lot of things. I think it's a great innovation platform in the design and manufacturing, I would say. So I thank you for that, by the way.
You're going to make my development team very happy. Thank you. And Scott, last but not least.
Totally agree on the APIs. It was a great experience integrating with Fusion to be able to send files back and forth. And kind of what we were alluding to before, it's impossible for us to give our users everything they need. And when you're even in the quoting process, you're still dealing with CAD and CAM on the manufacturing side, because maybe you need to model a fixture, or maybe you need to actually change the model because your customer in an email thread said, make it like that, except for this. And maybe you need to go make the change for them, or deal with some manufacturability issue. And then, of course, on the CAM side, if you're trying to estimate a cycle time, great to be able to actually run something in the CAM tool. So the ability to seamlessly move that data back and forth, right, in a way that's secure, it's not sitting on a workstation desktop, or it's not in a shared drive that isn't locked down properly. So that secure and reliable communication between the systems is huge. And then maintaining the revision history in the thread, so that when you do make that change, you don't lose track of the history of it, is hugely impactful.
Scott, I think also Justin and Omar, and thanks to everyone in the audience for the comments. I've been trying to keep track of it, but while we're talking, it's been hard. And your questions and feedback are always appreciated. Our team has been collecting and organizing your questions. We're going to try to bucket them. If you don't hear your question, just be patient. And also, you can always email me. You can probably figure out, or ping me on LinkedIn, and we will answer your question as it comes. If you, we're answering questions in kind of topic groups, and we'll try to avoid repeating questions if they're too similar. So now let's jump into the Q&A, and I invite back my three colleagues, Scott, Omar, and Justin. And here we are. So we're going to start in a couple different categories. The first one, I think, with AI, I think one of the biggest topics is efficiency and optimization. This is a big one that I think all of us we see the promise, but we don't understand it yet, and how it can affect our businesses, even how it affects myself as a engineer, manufacturer, you name it. So the first question I have is, what role does AI play in predictive maintenance? And how can Autodesk solutions optimize machine uptime and reduce costly repairs in manufacturing environments? And I'm going to start with you, Scott, because I think paperless parts probably plays a big role in
this. Well, I think preparing for it and accounting for it's huge, and that goes into we interact mostly at the quoting side, so making sure that if you do need long runs on certain machines or special tooling, that you're accounting for those costs and accounting for it in your schedule, so that you're not surprised when something doesn't get shipped out on time. But you guys probably are more tied into the or maybe Justin, I don't know. Are you more tied in on the predictive maintenance side? I'm not sure.
A little bit.
He was the next one I was going to go to. So great, Justin.
Obviously, Toolpath owns Chatter, which is a machine monitoring solution. In terms of predictive maintenance, I think the critical thing is actually to start measuring your spindle time. You start with the basics, though, like how long has it been since I swapped my coolant or checked the coolant concentration? How many spindle hours have I had? When's the last time this tool was replaced? How many hours in the cut does that tool have? And if you're not measuring any of that stuff, then it's really hard to get a really efficient predictive maintenance schedule. It doesn't mean you can't have an effective one, though. Like, you could just replace things on a regular chronological schedule that's kind of empirically tied. Like, oh, I check my coolant once a week, and Once a year I do spindle maintenance, that kind of stuff. But I would say, how can AI help? To be honest with you, AI can help only insofar as it can detect trends in what you measure. So for example, if you are a production shop and you have been running this part for 6 months, and over the last month, you've seen your spindle effort kind of creep up, your spindle load creep up as you make that part. Okay, well, something is wrong there, probably a tooling issue. It could be a spindle maintenance issue. And so it can help give you that early warning. But step one is measurement. And if you don't have any kind of measurement system, the AI can't help you. AI needs data and it has to be piped in. So I would say you start with measurement. However you choose to collect that data, whether it's by hand with an ERP or something, or some kind of automated solution. And then from there, you can start piping that into AI to help it identify trends. AI is really good at that.
Can't agree with you more. So our next question, I'm gonna go with you, Omar, on this one. What role does machine learning in optimizing the overall efficiency of manufacturing workflow? And how can Autodesk AI solutions specifically enhance this process? I wouldn't even limit to Autodesk AI solutions, but also how are our partners working with us on this?
Well, this is a great question because it goes back to the fundamentals. When we talk about machine learning technologies or AI technologies, we talk about prediction. It's algorithms, models that are able to predict the future. And at the moment you have such a tool, it's a crystal ball that you can look at and look at the future. You can run scenarios of multiple parameters, and therefore you can start running optimization. I want to machine this titanium component with this tool in this system. What is the right tooling and feed and speed for that? And once you have this tool able to do the prediction, you can use it to run and process plan, do a better process planning for your work. So I think AI is literally immediately referring, in my mind, to the possibility of finally running optimizations. So I think this is really the core messaging. AI is prediction. Once you are able to do prediction at low cost using capabilities of compute, you can do optimization. So now there are multiple tools that are defining manufacturing layout, manufacturing processes. Autodesk is one of them. Toolpath is one of them. Our solution Amaze is one of them for additive. So all of these are using the same fundamental that I just described, helping you solving your specific problem.
Yeah, and Scott, do you have a answer to that as well?
I think that's really well put. I'm trying to think of another area. There's a lot of knowledge you gain over the course of manufacturing all sorts of different parts. And an area where we see ML really helping is identifying similar parts or similar jobs you've either designed or manufactured before, right? So you can kind of benefit from what you learned on those. So you're not coming at it cold every time you see a new part. You can know this is how I machined that pocket last time, or I achieved that difficult feature, or looking at other ways, having that help you find other ways to solve a problem. Like, I could start from a different stock piece, or get like a precision work piece to start from rather than something else. So I think that's huge. It helps you kind of access what you and your company have learned, really quickly. Whether the human who's receiving this new part remembers that or not, right? The system can help you go back to the past experience you've had with it.
Okay, and then Justin, I got an easy question for you. Hopefully it's easy. Will AI allow for less waste and higher profitability on the first time?
Honestly, that goes right back to what Scott just said. I think capturing tribal knowledge is one way that you can really help reduce waste, right? Like, we made this part 2 years ago. Well, I didn't work here 2 years ago, so let me at least know that happened, and I can go look that up. But beyond that, I think the easiest waste for AI to help with is in avoiding costly mistakes. It's not usually the quotes you get right that hurt you, even if you win or don't win them, right? If you win it, if you're off by a little bit, it's the ones you get really wrong. I ordered, I just completely missed a setup on this part, or I didn't realize there was going to be like humongous amounts of thermal residual stress in this print, and I literally can't print it without major design changes. And so AI kind of helping to catch those like really outside the standard deviation bounds Those are the ones that I think AI can have the most immediate impact on. I
I
know.
want to.
Oh, go ahead.
Yeah, go
I
ahead.
just want to add to what Justin said. I mean, and obviously, we're trying to explain to people that you have been building experience based on trial and error, as Justin said. But there are just some manufacturing process where there is no room for doing much trial and error. You cannot understand the process. How can you get into a black box of 3D printer now and try to understand what's going on over time? So, to your point, Justin, it's replacing that expertise, or in the case where you cannot build that expertise, having that expertise.
Completely agree. So this next one is coming from a software engineer. What are you doing in the mechanical engineering section or manufacturing? But congrats. Manufacturing seems to traditionally be consolidated to large specialized factory floors. By your measures, do you foresee AI tool chains enabling greater degrees of distributed manufacturing to achieve things like supply chain resilience? This is a complicated one, especially I know that we have a lot of global factors going into this one. And I'm going to start with you, Scott. What do you think?
I think supply chains are already, widely spread. They're all over the world, and a typical product you buy has parts manufactured from many different suppliers. And what you might be thinking of is that last step where it's all coming together on one large kind of assembly floor, and that's where that final assembly happens. But stuff is sourced from all over the world. So I think when it comes to resiliency, where AI is really going to help, if you are an OEM, a big company manufacturing a complicated product, it is very hard to find reliable sources of supply for difficult to manufacture components. So, I think it's absolutely the case that AI is going to help them connect with suppliers, make really specialized manufacturing more accessible by helping with the communication and by helping also identify like who should these parts go to, right? Because you can't just send your IP to 20,000 manufacturers, right? You need to try to find good fits for the components you need manufactured. So I think that will be huge, right? So things aren't always sole sourced or aren't always coming from the other side of the world. Like you need to have options for critical components.
And Justin, did you have any ideas on that one as well?
Yeah, I'm not sure I agree with the premise that all manufacturing is done in large groups. Certainly lots of manufacturing is done. I think it depends a lot on whether you're talking about production or prototyping. But like Scott said, there's, tier 1, tier 2, tier 3 suppliers. And oftentimes those bigger guys are sourcing parts from smaller guys. And then those guys may be outsourcing some of that. I think you might be shocked how many critical parts in a Boeing aircraft or a Chevy truck are made in small, made in small 1, 2, 10 shops. And certainly like at the final production scale, that's probably not true, right? Mass manufacture. But there's a lot of prototyping and small run production that does get done. I think one place AI can help is by giving people a much quicker filter. A part that's really good at my shop may not be as good at your shop. And so having the ability, like Scott said, to find like, oh, well, let me go find 5 shops who would be really happy to take this part. That's very hard. And it's sort of mind blowing. At Toolpath, we talk to a lot of people trying to get parts made and a lot of people making parts. And the people making parts often say, well, how do I find new customers? And the people trying to get parts made often say, how do I find a shop who'll quote my job? And so there's a disconnect there. And there are companies out there trying to bridge that gap. And we're working toward it. But one of the challenges there is that quoting can take a lot of time. And if there's not a quick and easy filter for, yes, that's a good part for my shop, or no, that's not a good part, then it doesn't scale, right? We can't have every company sending their RFQ to 700 shops. The shops would never get any work done. And so you need some sort of automation, some sort of AI to help, at least down select, like, here are the 10 parts that you got asked to quote today out of the 500 that are probably a good fit for your shop.
Well, that's great, Justin. And this is my last question of the day, and then we're going to close out. And I think this is probably one of my favorite questions for all three of you. How can AI best help companies close the gap made by the mass exodus of senior, experienced employees? Many clients struggle with knowledge transfer to younger employees. What role, if any, can AI play in this situation? I'm going to start with you, Omar.
Well, I think this is ultimately one of the biggest use case for AI in manufacturing. I think ultimately being able to accelerate what engineers existing in the ecosystem are doing today will enable them to be more effective and buy us time to bring more people and excite more young people to come to manufacturing. I think this is the biggest use case for the next 10 years. How can we bring technologies to make the superheroes out there even more productive while we are already building excitement around manufacturing? And I think, our companies are representing this from the platform that Autodesk is providing to the machining use case, to the 3D printing use case, to the quotation use case. And all of these are working together for this same purpose.
Love to hear it. Scott, what about yourself?
I definitely agree with all that. That also reminded me of what Justin said earlier about one of the first steps in adopting AI is getting organized, getting your data in a way where it can be consumed and then leveraged. So if you've got really important institutional knowledge, captured in brains that want to retire soon, whether you're on the design side or the manufacturing side, you've got to get these folks into systems, using tools that are going to kind of be able to observe and capture that work so that tribal knowledge does get encoded in the system. And, especially for smaller companies, that's the difference between, having a company that is worth a lot of money and can be sold or transferred to the next generation versus, a shop that's going to be basically sold for machines.
Justin.
First of all, I'll open with a warning. If you are at a company and you feel like you're in danger of losing knowledge, AI does not fix the problem for you. It can be a great way to collect that tribal knowledge, but it still requires you to make a concerted effort, right? Like you're going to have your junior engineers, your junior manufacturing folks putting things through that AI system and then going to show the results to your senior people and say, is this good? Is this bad? Tell me why. So it's a powerful tool to help accelerate the learning curve for new people entering the industry. I would not be shocked to find that you have a lot of people who are getting ready to leave the industry who want nothing to do with it, right? And are just going to be real resistant. And so putting a system in place where you have newer folks using the AI to extract some of that knowledge and experience from the older folks without them resisting it, I think is a critical step. But that being said, I think capturing that tribal knowledge is the key. It comes back to what's a good part for my shop, or how do I make this part, or how do I print this, or should this be printed or machined? Those are the kinds of questions that you really want to embed your company's philosophy into your AI for, so that it gives the answer that, Toolpath Labs R&D shop likes versus paperless parts R&D shop, right? And I think if you can get there, then there's a path forward for you. But if they all leave, if all your domain expertise leaves, and then once they're gone, you turn to AI and you're like, okay, what next? You're in big trouble. So I guess my closing message is, if AI is going to be helpful there, you better start adopting soon. Don't wait till it's too late.
Can't agree with you more. First of all, thank you to everyone who attended. The chat has been amazing. I've been trying to keep up, but gosh, it's been hard for me to keep up and talk at the same time. So that's it for our time today. Thank you to all of our panelists here today. I hope you guys understand we have like 3 of the industry leading panelists here, and I would love to thank all 3 of them for taking the time to help us. And I hope any of you guys can reach out to us anytime. I'm pretty sure all of us will respond and make sure that we answer any questions. But if you do also have any questions, please ping Autodesk Design and Manufacturing, and we will make sure to forward it to the right person. And thank you to the audience for watching and engaging. It's been awesome. We will make sure to get to the remaining questions answered. I probably have like 10 more questions on my to-do list, and I can't even imagine how many more got added. So we will be following up. Follow the Autodesk Design and Manufacturing LinkedIn page and stay tuned. Make sure to let us know if you would like us to do more of these. I love talking to these guys, so if you want me to talk to these guys more, just let us know, and it'll be the best day of my life. And if there's any specific topics that you guys would like, please also share that. And please, until next time, we love to see anything that you guys have. share anything, any questions, any comments. We love to see your designs, what you're working on. We love to see everything. And have a great rest of your afternoon.